is 1. This is a parent or ancestor of the 5. Okay, in this case, we need to we need to divide at the beginning all the values. Yeah. For example, if here appear the 10 and x it's equal 0 and y it's equal 10 is false because both are in the same have the same parent or ancestor. And basically my idea now is only divide this, obviously pass this value here and this no. No. Let me check. But in this case, my doubt is why, okay, I understand this, but why this and this are different if on the final have the same ancestor? Okay, let me check, maybe I am wrong with my interpretation. 5 and 1. 5. Yeah, why? Okay. The question is the cosine sample. Cosine are those which are in the same. Yeah, I have the same though. This guy have the same doubt that me. Or has, sorry. There is a test how can I say? 93. It's the 5. No, this is wrong. No, this is different. Because in my case is 5 and 1, no 5 and 3. I don't understand why I put the answer here. Why this problem? It's 1, right, left, x is y, x is 5, and y is 1. Why? I don't understand this. Why this? Okay, maybe I can follow this. No. But I still don't understand why this is considered the answer that the spec is false. Why? Oh, I can copy this. Why? I don't understand why. Because in this case, in the is x it's equal 5 and y it's equal 1. Is basically this and this. Okay, now the parent of this is 3 and the parent of this is 2 and the parent of this is 1. Okay, but the first parent is 3. 5 have the dip the 1 2. One moment, I am returning true. Why true? Got it. It's not for the dip, it's not for the parent, it's for the dip. In this case the dip of this is 1 2 3 and the dip for this is 0. Why I return true? Okay, this is an error, but in the code. Here is less 1. The first is the parent is less 1. Okay, it's one value that never exists here because all the values here are greater than and now if we receive the node it's for this. Well, I don't feel as a medium problem. I think that, or I don't know, maybe, but fortunately I feel as an easy, like this mentioned, but many people say that it's a medium. Even previously, I marked this as a medium. Let me check. Oh, I tried it before. But well, means that I think that means that I improved, because I considered this problem as a medium problem before, but now, well, it's easy. But well, parent, simple solution using DFS, Java, and I push here. Okay, now it's time to try with the cousin in the binary tree 2. One sorry, it's in Spanish here. I'll go in yeah, okay, I think that it's okay. Nice. Now it's time to the second, this. Got it. Now cousin binary tree 2, and in this case this is the problem, and is given the root of the binary tree. Replace the value of each node in the tree with the sum of, given the root of the binary tree, replace the value of each node in the tree with the sum of all its cousin values. Two nodes of the binary tree consider okay, the same rule. Return root of the modified tree. Note that the type of the node is the number of edges, blah, 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 blah. This is similar, but we need to modify these values. What? Okay, let me check the constraints. It's between 1 and 50,000, I think. And the values is between 1 and 4,000 or 40,000. I don't know. I'm not sure here. But well, in this, what is the meaning of replace the value of each node in the tree with the sum? Okay, for example, here. Now with the value 1 has a cousin with the value 7. That is this with this not, because have the same parent, is with this. But one, the node with the value 1, this have a cousin with the value 7, that is this. So its sum is 7. Why is 7 if it's 1 plus? Y is 7. Node with the value has a cosine with the value 7. So its sum is same 7. I don't understand why is 7. Okay, I understand that the 1 is a cosine of 7, but in the problem set, sum of all its cosine values. Y is 7. And our node with the value 10 has a cosine with the value 1. No, with the value 7, so its sum is 7. Y is 7. Note with the value 7, this has a cosine with the value 1 again, and this, and it's 11. Oh wow, is a higher acceptance rate. Okay, this is a good point. Yeah, I agree. Yeah, I agree with this. Okay, but I don't understand. I need to understand why. Okay, he said. Hey bro, what's up? ¿Cómo estás, compa? I'm trying to solve this problem, but I don't understand this point. Here is the problem said that basically the cosine is the node that have different parent and have the same dip. Now, for example, this, no, this and this are cosine because have the different parent, because the parent of the 1 is 4 and the parent for the 7 is 9, okay, and the dip is the similar because it's 1 2 1 2, okay. In this case, again, this and this are cosine, yeah. But now why and even appear here 1 and 7, this and this are cosine, so its sum is 7. Why is 7? This is the point that I don't understand. Given the root of the binary to replace the value for of each node in the tree with the sum of all its cousins. La suma de todos los... Why is 7? I don't understand why is 7. Maybe I don't understand one point or not, but the sum of the sum of all its cousin values. In this case, the cousin are this, and the sum of the sum of the values is 1 plus 7 should be 8. Why appear 7? Oh, okay, got it. Yeah, makes sense. Makes sense. Yeah. For example, let me move this and try to follow this logic. Yeah, I understand. What? Ah, sorry. Okay, now, for example, this with this, got it. Yeah. In this case, the cousin of this is only 7. 7 plus nothing is 7. Okay, they change to 7. Okay, got it. Now the next that is this with this. In this case is 7 because the is, yeah, basically it's copy the is the sum 7 is the only one 7. And now we have this that have, in this case, have two. This and this are the cousin of this, but in this case I need keep the previous value or the original value. In this case is 10 plus 1, it's equal 11, and for this reason here should be appear as 11. This is 7, 7 and 11. Okay, got it, thank you. Yeah, but you're right. Is this is the meaning of sum of all cousins. But now, okay, the first point is that we need to consider that duplicates. This is the first point. The next that is keep the original value. Okay, I feel that this is a problem that need a hash map, and let me check. For example, if I start here, I am thinking in BFS for this. If I start here, well, basically is the first. Don't have anything, still in the same. Now we are here, the 4 and 9 is not possible because both have the same parent. Now move with the next, that is this, and in this case, this have the parent of this, and is validated with the next, but have the same parent, and is validated with the next. But in this case, it's different. The parent is different, means that I can apply the sum here. Now it's the same with this. It's the same with this. This doesn't exist more. It's with the next. Have different parent. Yeah, this is 7. And now is this, but don't exist more elements. I think that with the problem with the contest is okay. It's more tricky. I think that I prefer use paper for try to understand this, because the solution use the hash, but yourself hash, and it's very new for me. Let me check. For example, here, yeah, basically is create the hash, but I don't know. Okay, it works, but you know, I don't feel comfort with this solution. I don't know why, but the first point is try to understand how create the hash, because it's my first time to with this topic, to create the hash. No, use the hash map is another thing. Is to create hash. For this reason, I prefer first study and understand how create this and how works this. And next to is okay. Let me check your solution. Oh, but okay. Let me check. Then, bro, this looks like as a Martian solution. Let me check. Pre-computer flag. Wow. No, this is advanced for me. This is so advanced for me. But well, I think that it's a little step by step. But wow, it's impressive. Yeah, I never seen this topic about create the hash, but well, this is the solution. It's completely different to my approach. Okay, let me back to this. I don't know how many times I have this. Okay, maybe 10 minutes more, and that's it, because I need start with another session, but with English, because I need improve too. Well, this case is 7. Okay, now with this, I think that it's a BFS, but with the difference or the extra step with the DFS is basically, for example, in this case, at the beginning of the execution or the performance of the this operation is copy these values, yeah, or this node, sorry, and validate this, okay, excluding of this element, and search the cousins, yeah, and in this case this is removed, but it's not removed of this. Why? Because on the final I need to you you know what, it's not necessary because I can, yeah, for example, if I am here and I start searching the cousin of these elements, is this? No. Is this? Yeah. In this case, the cousin of this is 7 and the cousin of this is 1. And that's it. What happens if I have another element? Yeah, it's the same. For example, if you have another element here, it's basically, is cousin of this, this node? No. Is cousin this? Yeah. Here is 1 and here is 8. This is cousin of this? Yeah. This is 1 and this is this. And in this way, I don't need create a copy of this list and blah blah blah. No, because this basically is the only is this and this. Okay, now the next that the cousin of this is this, and here is 7. Yeah, and we have the answer here. Okay, now another point with this is that when we start here is the only one and don't have another elements to compare, well, it's 0. Now here I think I need create maybe a pair or yeah, no, a pair, no, an array of the nodes that the first is the parent and next to is the current node. Yeah, for example, here the parent of this is null because it doesn't exist and the node is 5. And now move this a BFS here, but in this case the parent is 5 and the node is, well, this node. Okay. Par u where it's basically only have the track over the parents, but I can use directly the value because these 3 allow the duplicates. Yeah, for this reason I use the it's a BFS. It's basically a BFS, but with the difference that we need to add an extra steps. Yeah, and in this case is sorry, today I feel a little lazy with my mind. Q in this case is an integer. Integer, no, it's 3 node. It's an array of trees or 3 nodes. Q it's equal new linked list. Always I wrote wrong this word. Linked list. I am thinking in LinkedIn. Linked list. Okay, and now the next that is q.add q java, it's add or append. It's add, and in this case is new 3 nodes, and the values are the parent is null and the value is root, or the node is root. Okay, now here basically we have the next structure. Here is null, parent is null, and the value is, or the node is the node 5. Okay, now we know that the first element. Why not DFS? Because with the DFS, for example, I am thinking in this case, with DFS, when you reach this, how know which another nodes are the cousin of this? You need to go to this side and validate. Okay, we have another element in the same level. With two TVS. But for me, at this moment, I feel that take more sense if we need to validate the level, the BFS bind much better with this problem. Yeah, because with the BFS, basically all the time, you are in the same level. And with this, you avoid this problem to validate the is the same level or not, and blah blah blah. It's only you need to consider that valid if the nodes are have the same, if the nodes have the same parent. Yeah, in this case, have the same parent is aren't cousin. Have different parent are cousin. Yeah, but well, take more sense for me. Use the BFS. I think it's only the one reason. The only reason, sorry. Okay, here now the next stat is the while. And in this case is meanwhile, or while q is empty, negative obviously. In this case is tree node q their size is equal q dot size for know how many elements are in this level. In this case is 1. Now the next stat is tree node n it's equal no it's equal q dot remove okay, but in this case, for example, imagine that I am here, I remove the 1, I need to know I need transversal the q between this and this. I don't like this. Q operations Java. No. Okay, offer, insert, element, pick, remove, pull. Okay, before to end this transmission, my last talk about this is that I have a queue here with these 3 elements, but I can know the next elements because I need to remove, apply the pop and these kind of things. I think that in every iteration, reset and fill a map with the basically value and parent, value and parent, value and parent, yeah? And where we are here, basically ask over this map which other elements I have. For example, I need transversal. In this case, if I transversal, basically is the same if I am using a hash map or a list. Okay, if I change for a list, basically the list contains these elements, and I start with this, and ask this have the same parent. Yeah, okay, it's ignored. Now the next, these have the same parent. Yeah, and this and this. Well, I think that I need to use trackings of, yeah, a hash map, where the hash map is the node, and the value of this hash map is maybe another an array with two values. The first is the node, and the other should be have the current sum of the cousin values. Well, I need to clear to invest more time, but well, thanks for following this transmission, and I hope see you in the next. Thank you, John, for the comment, because I really don't understand in the moment this, but well, thank you and see you later. Bye bye.